All right, space weather enthusiasts, we've got 2 CMEs on the way, also a coronal hole high-speed stream, and additional coronal mass ejection likely headed this way as well. So that makes 3 total. A very high likelihood of large solar flares now emerging in the northwestern limb. We'll talk all about it and lots more here at the Smash News Network, least busted name in news. Another exciting day for space weather. Unfortunately, we're going to have cloudy skies over Lehigh Valley. So while the aurora may be coming up to mid-latitudes in the coming nights, tonight and tomorrow night namely, we're unlikely to see them in Pennsylvania because of the storms. So we've also got a bunch of plasma filaments here, like that crown prominence you see up there hanging out around the North Polar region. Again, a very high likelihood of large solar flares, especially in that northwestern limb. We've got multiple magnetically complex sunspot groups there approaching their setting mode there in the northwest. Also, a new active region is rising in the southeast. These wavelengths are great at showing filaments, active regions, the extended corona. That's why we tend to show this 24-hour video type view. This is 304 plus 193 angstroms from the SDO, the Solar Dynamics Observatory. So now, if you enjoy the content, take a moment to press the like button. Help us out with the pathetic algorithms. And press like. Maybe press share. And congratulations on realizing that the content exists. No big deal. It's only the world's most comprehensive daily space weather content and most detailed solar imagery. No big deal. We do meteorology segments as a value-added service. As I discovered like 2 decades ago, it's way too easy to forecast the weather, so we throw that in. So, yeah. Congratulations on realizing the channel exists. Press the like button, press share, leave a comment, etc. If you haven't seen the shorts, check them out. They're a great way to share little tidbits of the daily space weather content with your friends and foes who have short attention spans. I know the videos are like 50 minutes long lately, but there are a whole series of videos under a minute in length. They've become pretty popular, as you may be able to tell there. So, yeah, thanks to our new subscribers over on YouTube. And once again, congratulations on realizing the channel exists. We're frankly surprised. Now, this video does include paid affiliate/sponsor links. One of them is to our Amazon shop, and when I'm feeling under the weather, I like to take mega doses of L-lysine. So, took 1,000 milligrams of it this morning because not feeling particularly well. So, you may want to supplement that. Save 41% right now on the L-lysine from our Amazon shop. It's at amazon.com/shop/smashomash. You can find other lists there with all kinds of other stuff. Another one of our paid affiliate/sponsors is the Hemp Lucid shop. You can find links below the video to the Amazon and Hemp Lucid shops. You can also find those links on the home page. So if you want to help the channel out that way, pick up some tangible products. There are sales going on the mushroom stacks there. Save $15 on those. And those lip balms are so popular that they are out of stock. Again, links below the video in the description to the Hemp Lucid store. So help out the channel that way. Give Smash staff a raise, as she makes just this side of nothing to be our IT department and our social media management. Next is our featured product of the day. Today's featured product is not the one I'm wearing, because mine contains terminology that shall not be said on YouTube videos. I also have the socks. I guess you can't really see them. But today's featured product is our most popular product. Now, the one I'm wearing right now was the most popular product for over a year, but today's featured product is the current most popular. Do not pole vault the caldera, folks. I know it may seem like things could not possibly get any worse, and they certainly can get worse. However, if you're going through hell, keep going. And indeed, our finest days do lie ahead. Civilization is not ending. Sorry, doomsday's been canceled. So help us advertise. Go out in public and get blank looks from people when you tell them that you watch Spaceweather. Yes, Spaceweather. And then when they realize the implications of Spaceweather, maybe they'll have less blank looks. I don't know. But the Do Not Pole Vault the Caldera product does feature our homepage, smashomash.com, as well as the YouTube URL. That's today's featured product, not this one, because, again, it contains words that shall not be said on YouTube videos. And yes, the world's largest problem is currently censorship, certainly. So once again, you can find those links below the video in the description, as well as on the homepage at smashomash.com. And welcome to the Neo Renaissance. Permanent invite link to our Discord channel and lots more there. Hit us up on social media. If you want to send a message, there's all kinds of ways to reach us. And let's get back to taking a look at the closest star here. This is the SDO continuum there. And that's what over 200 sunspots looks like. And we're not even at solar maximum yet, likely. So we have seen a small dip in solar activity since yesterday in terms of some of the features. However, we do see umbral growth here around that northwestern limb. So very high likelihood of possible X-class flares up in this region. So that depicts yesterday plus today. That's September 22nd and September 23rd to date. Here's the colorized magnetogram for that same time frame. And let's take a brief look away from space and see what's going on planet Earth, as we have a number of volcanic eruptions occurring. Tsukunosejima is producing a 6,000-foot plume of volcanic ash. Please do not pole vault the caldera. Mount Mayon produced an unknown-sized volcanic ash plume there over Luzon Island, Philippines. And Merapi on central Java producing some rather extreme activity here, including seismic signals, block and ash flows, pyroclastic flows, phoenix clouds. It's exciting times there at central Java. Mount Merapi erupting. Semeru also erupting on East Java, Indonesia. That's Semeru exploding there, flight level 140. Dakono exploding, flight level 070. Moving down to North America, Popocatépetl exploding in central Mexico. It's a 20,000-foot ash plume, 15,000-foot ash plume over Fuego in Guatemala as it explodes. Nevado del Ruiz exploding in Colombia. Actually, just occasional emissions there. Sangay, occasional emissions. In Ecuador, Revenador, volcanic ash not spotted. However, Sabancaya is erupting in a spectacular fashion, producing intermittent puffs and a 26,000-foot plume of volcanic ash as it explodes. It's a flight level 260. Please do not pole vault the caldera. It could be unhealthful. Next, seismic update. And what's shaken? Well, I wonder. Here come the quakes of a 5 or greater magnitude for the past 24 hours. A 5.8 hit Indonesia at 14:59 Universal Time yesterday afternoon. A 5.8 there at 155 kilometers estimated depth. Followed by a 5.4 at Vanuatu, well to the east of that Indonesian quake. That 5.4 was at 16:19 Universal Time and much shallower at 40 kilometers. Then about 20 minutes later, a 5.0 struck Japan. So the Western Pacific here for the past 3 days has been by far the most seismically active region of the planet. The Western Pacific Rim, folks. And remember, folks, any earthquake, even a large one, can be a foreshock. So don't assume that a large quake is the end of the shaking. If it's a foreshock, it is a pre-earthquake signal. And that is my signal to get back to space. Here are the past 24 hours in SDO 304 angstroms, the classic wavelength. And you can see one CME happening right up here. You see right in here, right there, you see some limb darkening. That's some material exiting from that active sunspot in the northwest. There's also some activity right in the center of the solar disk here. That was late in the day yesterday. There's that Hyder flare as material splashes back down toward the chromosphere. The layer between the photosphere where sunspots occur and the corona, the atmosphere, which is what's actually depicted in this imagery. You can also see some brightening of this region. So lots of stuff to talk about when it comes to solar activity. And how about 171 angstroms? Smash staff. I said 171. Or it's a beating. Just kidding, folks. It's a beating regardless. So there's 171 angstroms, another 24-hour video. And again, we do have one more active region here rising in the east. I suspect it probably is a sunspot as I see a very bright area there. Here's a little closer zoom. So that's the equatorial view. And here is that new active region rising. If I had to guess, which I don't, I would say it probably is a sunspot. It might even be visible by the time we get to the end of this video. So make sure you stay tuned for our high-res imagery of the closest star. And let's talk stats. The 10.7 centimeter radio flux is next, and it is now at 176 solar flux units. While the sunspot number here remains over 200, so that there's the radio flux depicted by this black line here. 176 is the new number for the F107, or the 10.7 centimeter radio flux. The 2800 megahertz solar radio emissions. Next, the Space Weather Enthusiast dashboard here, and you can see we have a forecast coming for the next 2 nights for geomagnetic storms tonight into tomorrow morning, and geomagnetic unrest Sunday morning into Monday. So there you go. That's the Space Weather Enthusiast dashboard. There's a coronal hole and 2 CMEs on the way. And here's the Enlil spiral from NOAA. That's NOAA's forecast. So the coronal hole high-speed stream is showing up late. And then CME's expected to arrive tomorrow. And by the way, yeah, there's another one coming on the 25th. We'll get to that later in the video. Here's NASA's forecast. NASA doesn't have that latest CME forecast either. But there you can see the sort of a glancing blow there. Mostly expected to miss to the north, as you can see on this center pane. We'll let that play through one more time, and then we'll move on to take a look at Earth's magnetic moment from space. Here it is, the past 4 hours. And we're seeing a weak solar wind for the past day or so. Again, that coronal hole high-speed stream showing up late. We're awaiting a density spike, signaling the incoming coronal hole high-speed stream. We don't see it yet. It is geomagnetically calm. Again, that's the last 4 hours of Earth's magnetic moment from space, depicting magnetohydrodynamic pressure. Here's magnetic flux density from the ground level. Our ground magnetic perturbations map there. Again, the last 4 hours, Earth's magnetic moment from the ground. And if you're wondering about Doomsday, Doomsday has been canceled. Sorry about that. Nibiru, the Apocalypse, Planet X, the Galactic Current Sheet, the Solar Micronova, it's all canceled. Grand Solar Minimum, canceled. Sorry. The Apocalypse has been postponed indefinitely. That's the past 4 hours of Earth's magnetic moment from the ground, and we have a, again, geomagnetically calm condition here. KP 2.67 is the global average of geomagnetism. Planetary K index 2.67, and it's moved to the real-time solar wind here. The Discover spacecraft showing up with about 350 kilometers per second for the solar wind speed. Make it 370. Solar wind density here very diffuse at not even 1 proton per cubic centimeter. So a very diffuse and rather slow solar wind, folks. When we see the coronal hole high-speed stream show up, you can expect to see a density spike, followed by a decrease in the density, followed by an increase in the solar wind speed. At the moment, slow and very diffuse. Here are the GOES magnetometers there, fairly smooth for the past couple of days. Earth has recently moved into a North Pole current sheet. And here is our top view ecliptic plane field plot. And welcome to space, a frontier. That's what's going on in terms of the polarity of the Parker solar spiral. So we have this large North Pole oriented current sheet there, depicted in green. Earth snapped across there right around when we made yesterday's daily space weather show. Next, our line of sight field plot. The blue depicts the solar B field, by the way, if you're wondering. Polar fields are in green and red. Photosphere magnetism is in grayscale. And let's move to coronal holes, a super important factor in solar cycle progression. Yeah, coronal holes, they stay fixated at the poles around solar minimum, and then they migrate across the equator, switching their polar locations. So at the moment here, we do have the best, most well-defined coronal holes there are in the northwest. They are of South Pole orientation. We have a pretty even split here. These are South Pole coronal holes, and these are North Pole coronal holes. That's about the sector boundary crossing right there. Another 24-hour video from SDO, 211 angstroms, one of the many species of ionized iron. And we're going to show some close-ups of that coronal hole in the northwest, since we are seeing a minor uptick in coronal hole activity as forecast for the entire solar cycle, because we've been seeing a shortage of coronal holes, which will not continue. They must migrate across the equator, folks. So there's a great view of that one. And let's zoom in even a little bit closer there. This is effectively a solar radio jet, folks. There is material blasting out from this. Coronal holes are the source of solar high-speed winds. And that is unlikely to get to Earth because of its location so high in the north. But a great view there of that coronal hole, showing some fantastic depth in the sun's atmosphere. 211 angstroms is the optimal wavelength through which to view coronal holes. Next, we'll move to sunspots. Sunspots. Exciting stuff, because the sunspot number is currently above 210. So there is the Brussels sunspot number monitor. And it was at 220 here. Now it's at like 214, 215, something like that. And again, very high likelihood of large solar flares in various locations, and an increasing probability of large solar flares in that northwestern limb. So there you go. There's the flare probability monitor, and let's see here. So check it out. Let's see. Indeed, 3443, the most likely place to produce a large solar flare, showing a greater than 1/3 chance of producing an X-class flare at the moment. And let's move to our SDO videos. So here's a 24-hour video. It's SDO intensity gram plus 171 angstroms to highlight those active regions. You can see the way that particular species of ionized iron likes to orient two magnetic field lines there, low in the corona. The lower quiet corona is the 171 angstroms wavelength. Let's subtract the 171 here. So you may note some umbral growth there. So we don't have any major degradation here. Do we have any new sunspots? I don't think so. Actually, one did just form right here. It is very small. You might be able to see it better on the colorized magnetogram. Well, it's not colorized, the grayscale magnetogram. Which we will show next. And again, let's take a look at this northwestern limb. Rapidly becoming by far the most likely place to see a large solar flare. That sunspot up to the north of the Earth scale there. It is Beta Gamma Delta class, and it is approaching that limb. So Earth-facing quiet has expired long ago for that one. It is perhaps overdue to produce an M-class or even an X-class solar flare. And there it is in the SDO HMI Continuum instrument. And it's time for energetic particles and solar flares. The ghost proton flux remains flatlined here. Expect an uptick in this coming. Like I said yesterday, this is a forecast for solar energetic particle events. You can expect to see some. Why? Because solar flares are so likely as those active sunspots approach the limb. So look for spikes in the proton flux, some solar energetic particle events likely coming in the coming days. GOES X-ray flux here has reached a background level of around C1.5. So the uptick in the solar activity continues. It made it all the way up to about a C2 background level. And here, if you look at the 7-day graph, you can see how the past couple of days here have shown a big uptick. Not surprising with over 200 sunspots in the Earth-facing portion of the solar disk. And how about if we take a look at some flare wavelengths? Here's 131 angstroms, another 24-hour video from Solar Dynamics Observatory. Here's 94 angstroms. And we're going to show this northwestern limb. And we'll switch back to 131 angstroms. Major solar flare watch, and indeed, solar energetic particle event watch in effect. Next, we'll take a look at what's going on overhead. This is Lehigh Valley, Pennsylvania. This is from skyandtelescope.org. I like the star chart there, as it does a great job of giving you an idea of where things like the Andromeda Galaxy would be located in the constellation of Andromeda. So Jupiter's setting over there, even though we can't see anything because it's very cloudy and rainy, as huge, heavy bands of rain are being sent our direction from that subtropical system. Jupiter being chased by Venus and Mercury and the Sun. And in a little while, Mars will rise as well. So if you're viewing the early evening sky, you might get a great view of Mars there, low on the horizon. Next, our solar system forecast. And a shout out to David Dubine. Hey, David Dubine. These glowing planets, they represent retrograde planetary motion, not some kind of spooky electromagnetism. So that's all it is. It's retrograde motion, which means that those planets are not moving. The planets are moving in the opposite direction relative to the background stars. That's all those purple glows mean, retrograde motion. Anyway, here's our solar system forecast. This is where things are today on the 23rd. That's where things will be on the 30th. Looks like full moon falls on the 29th of September. And here's our astronomy photo of the day. So this is a pretty sweet one. This astronomy photo of the day features images of the sun at 4 p.m. each day in New Zealand. And then, 15 minutes later, the shutter was left open. This day on the solstice, the summer solstice, and this day on the winter solstice. So you can see how low the sun gets in the sky at wintertime at this location in New Zealand and how high it is at the summer solstice. So since it is equinox day, that's probably why that's the astronomy photo of the day. That is 365 images of the sun at 4 p.m. and then a time-lapse 15-minute sunset image. 15 minutes after 4:15 to sunset. So that's the apod.nasa.gov image of the day. And today's cosmology segment is, well, this isn't really cosmology, I guess, but OSIRIS-REx. OSIRIS-REx tomorrow at 10:55 a.m. Eastern Time is going to be dropping off a sample from asteroid Bennu. So that's exciting stuff. Here's a little dress rehearsal of what it will look like when that thing makes a landing there in the Utah desert, I believe. The Utah Test and Training Range and Dugway Proving Grounds, 80 miles southwest of Salt Lake City. So that's exciting stuff. We showed some imagery of Bennu just a couple days ago from OSIRIS-REx. I guess that's the cosmology segment. I don't know, but it's whatever. It's let's take a look at CMEs. Since we had some spectacular CMEs yesterday. And some additional coronal mass ejections today. So we'll do some analysis of these. That is a lot of events there on the 86 frames from yesterday. I mean, I don't even know how many that is. I have no idea. It's a lot. Most of them not earthly directed. That's 86 frames from yesterday. Here are an additional 23 frames from today, and today started out with a CME off to the south, which contains an earthly directed component. So we'll get to that next. So here's Soho-Lascaux C2 and C3. And yeah, multiple events there. You can expect CME impacts to continue on Earth for the coming 3 or 4 days here. And it's getting convoluted enough that I'm starting to lose track. So I believe there are 2 additional events here that likely have an earthly directed component. The 25th and 26th, we can expect more CME impacts, minor ones, not direct hits or anything. Let's try to break this down. So here's yesterday's imagery. There around midday, you can see a significant event happening. Actually, it kicks off around 9 o'clock. Multiple outflows happening there. And then later in the day, you can see events out of the northwest. Those do not appear to be earthly directed. Last but not least, first thing this morning, we've got this CME out of the south, And that likely contains an earthly directed component. So yeah, that's the one likely to arrive on the 26th. And we'll show you more detailed imagery of that, complete with the SDO. Before we do that, we'll show stereo A. Dag. It's exciting times for space weather, whether or not anybody sees the content on YouTube. You think YouTube's doing viewers a disservice with what it recommends for, quote, space weather, end quote, content? Anyway, there's the position of things like stereo A and Venus and Parker Solar Probe and Bepi Colombo and Solar Orbiter. And here come the stereo A coronagraphs. So difference imagery on the right, raw coronagraph on the left. We'll let those play all the way through, all 60 frames that we brought up here. So that one CME from yesterday does have an earthly directed component, and then the one from early this morning today also has an earthly directed component. You can see it right there. And we'll show you why right now. So here are our custom coronagraphs. We show these most days on the channel when they're available. And when we zoom in a little bit closer, you'll see plasma motions right here, right in the center of the solar disk. And then a lot of that material likely to miss Earth to the south. It is likely to have an earthly directed component because it's exactly in the center of the Earth-facing strike zone. So that's this morning's CME. The one from yesterday is kind of just on the tail end of this video. It doesn't really depict it. So we've got like 4 more days here of space weather coming. There's an even closer view for you. Watching this area right here, there's that plasma motion, followed by that CME that is mostly going to miss to the south. But again, is almost 100% guaranteed to have some earthly directed component. Here we'll zoom in all the way to show 193 angstroms. So a great example of how you don't need to see a large solar flare to see a coronal mass ejection, folks. We get this question all the time. How big of a flare do you have to see to knock down Earth's grids? And the answer is, you don't have to see a flare at all to knock down Earth's grids. Solar flares and coronal mass ejections are separate phenomena. A solar flare is X-rays. A coronal mass ejection is charged particles, protons, hydrogen nuclei primarily. Completely separate phenomenon. You can see a solar flare that produces 0 coronal mass ejection, and you can see a coronal mass ejection associated with 0 solar flares. We've covered it repeatedly on the channel. Solar flares are photons. Coronal mass ejections are protons. Don't get them confused. It is a big deal to keep them separated. So we're going to show these events from early this morning. There you can see this radio burst right here in the very center of the solar disk there. Again, most of that material will miss Earth to the south. However, some of it is likely to strike. So that's from our Twitch feed. A great example of why we stream Twitch all day long. In fact, we're streaming it right now. And let's move on to solar filaments. Solar filaments, they're what often turn into coronal mass ejections. And again, you don't have to see a solar flare to see a filament ejection. Filament ejections happen all the time with no solar flares, and solar flares happen all the time with no filament ejection. Coronal mass ejections and solar flares are separate phenomena. Anyway, that's the El Teide, Spain ground-based solar observatory depicting the last day of activity. We have a number of named filaments here. I won't get into it. If you want to name filaments, you got to do it on Twitter. Just follow the hashtag #NameThatFilament. Here's the grayscale imagery, which shows prominences. One of these is named Russell Brand. That one right there. And shout out to all of our viewers who follow us over on Twitter. And here come the last couple of hours from the GOES 16 SUVi. This is what we are typically streaming on Twitch. And it looks like there's a CME happening right up here. So no real surprise there. You can expect that northwestern limb to be the place to continue to see large-scale activities in the coming few days. In the coming few days, it's an exciting time for space weather. Again, thanks to our new Twitter followers. You can find discussions over there on Twitter that have nothing to do with space weather. So make sure you follow us there. And if you've unplugged from social media entirely, probably because of the pathetic, un-American, evil corporate censorship, then we don't blame you for that either. However, we do hold you accountable. And remember, folks, accountability always comes. It always comes for all entities. All entities face accountability. And the longer they wait, the more harsh that accountability is going to be, period. That's just the way it works. You keep kicking the can down the road, eventually the can is going to kick you back. So here come bonus features. Space Weather Enthusiasts Dashboard. This is the Satellites Community Dashboard, actually. Showing some minor surface charging hazards there in the East Central Pacific. Some low-energy electrons there building on the outside of spacecraft. Not likely to cause any major communications breakdowns, but there you go. Those are the facts. For satellite charging hazards, the GOES electron flux here just moving into warning levels for both the GOES 16 and GOES 18, an indication that the coronal hole high-speed stream is not here yet, as you can expect to see this crash when the coronal hole high-speed stream shows up. Yeah, it's called being able to correlate the data, folks. Whether or not you understand the physics, if you understand how the data correlates, then you've made some progress in your understanding of space weather. Here's the one-year forecast, the one-year graph, the 1 year of observations of the relativistic electrons there, as reported by solon.info/solar. And we are expecting electron storm levels to continue here until we get some space weather inputs like coronal hole high-speed streams and coronal mass ejection impacts. Here's NOAA's forecast, depicted by the green boxes. And NOAA is depicting a downtick in X-ray flux as well. That seems to be a sound forecast to me. What do you think? Let us know in the comments. We'll also show the layer where that's measured, the F layer of the ionosphere. Another indication that doomsday has not arrived, the way the ionosphere looks. So we show it daily on the channel. People are very spooked of pole shifts and spooky galaxy interactions and the sun going micronova and all this nonsense. So we show the F layer of the ionosphere, which is located about 300 kilometers of altitude. And here it is, the raw vibrational frequency. As that material is vibrating, it's very diffuse. And the part that is under the noontime side of the planet is very puffed up and very ionized by incoming solar radiation, because it's largely outside of the protective barrier of Earth's atmosphere. So that's the F layer of the ionosphere, folks. We show it daily. Here is the anomaly in megahertz from a 30-day median, and it's looking quite normally. No quadrupoles, no octopoles, just the South Atlantic anomaly in the normal place. The South African anomaly in the normal place right around the western equatorial coast of Africa. It's not looking spooky. And once again, doomsday has been canceled. I know you may want to see civilization collapse. Unfortunately for you, it's not. Anyway, here is the civilization might collapse. However, it's a result of humans self-destructing, not a result of nature destructing the world. It's been around a long time, folks, and it's not likely to go anywhere anytime soon. There's the latest image, 12:30 Universal Time for the ionogram. and 1230 Universal Time anomalogram. I can't believe it's controversial to say the world's not ending. Yeah, it's controversial to say the world's not ending. That's how many cults currently exist on planet Earth. We'll also show the total electron content because it shows a likely place for GPS errors, and also shows us how intact the Van Allen belts are, especially the inner Van Allen belt. Here's a total electron content forecast, and it's looking quite organized here, as it typically does when we see high levels of electron flux. Are there extra spooky Van Allen belts forming? Well, no, there aren't. If there were, you'd see them on this map, but you don't because they're not there. Just like you don't see Nibiru because it's not there either. Here is the anomaly from the 10-day average for the electron content over North America. Now, the total electron content is literally a count of free electrons. Those are fairly easy to count because they cause signal refraction. The satellite knows where it is, and the ground station knows where it is. And so they know how many free electrons are in between. We do have some minor anomalies here over the southern Caribbean and central Mexico. You'll see some red lighting up there. That's anomaly in electron content from the 10-day average. And we'll close out our space weather segment with the latest intensity gram and the latest magnetogram. So let's just take a look at the magnetic fields of these sunspots. That's beta gamma delta class. 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 So those are a lot of sunspots that could produce large flares. Again, the most likely spot in the northwestern limb up here. And that brings us to meteorology. Now, these videos are brought to you in part by the Smash team, especially the gold and silver Smash team level. So, thanks to those folks, there's also a bronze level there, which will cost you $0 per month. SmashOmash.com/Smash team. It's kind of like Patreon, just superior, because it has additional capabilities. So once again, welcome to the Neo Renaissance. Help out the channel by visiting our links. Hit us up on social media. Press like, press share, press comment. If you're an influencer, drop us a line. Maybe we'll appear on your channel. In all likelihood, we'd be more than happy to. And again, if you want to support the channel, become a member of the Smash team, especially at the gold or silver level. The best value is the gold annual paid-up subscription, as it's almost like getting 4 months for free, as it includes complimentary merch. By the way, happy spring. We're less than 6 hours into spring when this video was produced. Congratulations on surviving another winter, Southern Hemisphere viewers. And congratulations on surviving another summer for all of you folks in the North. Happy spring from the Smash team. We're starting out our meteorology segment by looking at mean sea level pressure. And there's going to be a lot of talk about the mean sea level pressure over North Carolina right now, but it's nearly 1,000 hectopascals. Not really that low. There are much lower pressures around the planet, like this low off the coast of Ireland. That's much lower. The seas are much stormier in that area. And if you want to see the lowest pressure in the world, it's certainly in the Southern Ocean. 939 hectopascals down there. That is hurricane force. Just keep in mind it's just coming out of winter, which means it's not going to be a hurricane. But that is the world's lowest pressure. The southern Atlantic there, just at the border of the Southern Ocean. Southern Ocean, kind of turbulent. Not the best place to be rowing your Viking open-top longboats. Anyway, let's blast through meteorology as a value-added service. Here are the surface winds of the eastern world. Shout out to our viewers from this side of the planet. Here are the surface winds, the jet streams, rather, of the eastern world. If you're in this part of the planet, make sure that you press the share button, as we have extremely low exposure in East Asia. Next, the jet streams of the central world, depicted here. Surface winds, depicted here. Surface winds of the west, And there are the west's jet streams. Next, we'll take a look at the environment north of that storm. And check it out. There's a lot of water to continue to aid in convection of that system. So the surface temperature there on the Chesapeake is 76 degrees. That is pretty warm water there. And there's where the low currently is located, right over southeastern North Carolina. So that is expected to move quite far to the west, actually. I think the model must have changed, but it looks like it's going to very much weaken there by tomorrow at noontime and then turn back to the east again. So that's the Euro forecast. The GFS forecast puts it in exactly the same spot. So those are two very inline forecasts there. Likely to be over one of the world's largest swamps, Washington, D.C. Next, clouds and fog over the western world as we zoom in closer and closer to the lower 48. That's our shortwave radiation map, part of the NASA GOES Interactive Weather Satellite Suite. And there is a close-up of that, I'll call it a subtropical system. A subtropical low, I guess, is the appropriate dictionary definition of what that actually is. Shout out to Chris Mart's Weather. Chris Mart's Weather, he likes facts. Probably why he's so controversial. Next, our weather.gov map, and you can see lots of warnings here, including some hard freezes in Colorado and Wyoming and Idaho. We'll scroll down to briefly show you the key. There are the weather warnings. If you have weather warnings where you're located, head to weather.gov, the National Weather Service homepage, and click your location. A bunch of flooding there forecasted for Maryland, Delaware, Virginia, North Carolina, and New Jersey. Here comes some forecasts. This is the 72-hour GFS pressure and precipitation forecast. So that thing is going to make a turn to the due east by Sunday. Heavy precipitation here coming to British Columbia and Washington, Oregon, and Northern California. Also the central U.S. there seeing some rather significant precipitation. Speaking of precipitation, here is our total accumulated precipitation forecast in inches. So again, it's a 72-hour GFS model. 72-hour GFS model. Some very heavy rains there. Dag, look at that. 6 inches of rain coming to parts of Washington. Also, over 3 inches of rain coming to large portions of the U.S., including the Dakotas, Minnesota, parts of Wisconsin, North Carolina, and especially Virginia. Some areas likely to see 6 inches of rain in there. Next, this is the temperature anomaly forecast for the same model, the GFS 72-hour. Just keep in mind that this temperature anomaly forecast is in degrees Celsius. Most of the country here anomalously warm in the coming 3 days. However, the left coast, mostly anomalously cold with some rapid and wild temperature swings there, especially in Oregon and Washington. Next, lightning. This is what's been striking for the past about 10 hours. And do we have any terrestrial strikes? And check it out. Look how straight this line is, folks. That is equinox day. Everybody's getting 12 hours of night and day. We do have some minor thunderstorm activity here south of St. Paul. Well, that's a pretty strong one there. I stand corrected. That is not minor. That's the kind of thunderstorm that's typically accompanied by damaging wind and hail. So eastern Nebraska there. Eastern Nebraska getting kaplasted as we produce the video. Oh yeah, that is nasty. That's the kind of storm that could indeed include tornadoes. See all the white on there? That, geez, that is a legit supercell, folks. Anyway, we're going to focus on the lower 48 here. That's Doppler radar. Here is clouds and fog. And there is water vapor. What's happening here in Nebraska is you've got this impulse of dry mass of air from the west butting into this high pressure zone, acting like a wall and creating a huge, essentially an atmospheric waterfall there over eastern Nebraska. Anyway, here's a recap to close this thing out. U.S. Doppler radar, clouds and fog, water vapor. Once again, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. I mean, the content's monetized. YouTube has a legitimate reason to recommend it. So, anyway, press like, press share. See you soon. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.